Hello again, and welcome to the next episode of You Can Do Math, Lesson 3, Multiplication. So multiplication is a way of rapidly counting equal-sized groups. So for example, if we had take a very simple example, such as if we have, say, two groups with 3 items in each group. That means we have 6 items total. That would be, 6 dots. 1, 2, 3, 4, 5, 6. Another example you could have of this would be to say, for example, if you have, say, so one 6-pack of soda, and it's 6 cans, right? So if I have, say, 3 6-packs, how many sodas is that? Oops. I was kind of sloppy with the question marks. So to write that out in numbers, we'd have 3 times 6, and that's 18. So to learn to multiply, it's important to learn things called multiplication tables. So of course we have 10 single-digit numbers, 0 through 9, and in school they usually, when I was in school, I was taught to memorize the multiplication tables from 0 to 12. So if you made a table like that, starting 0, you go all the way to 12. On the other way, you go 0 all the way to 12. If you filled in this whole thing, you'd end up with 169 products to memorize. The result of multiplication is called a product. So that's an awful lot of memorization to try and memorize 169 things. And I think I found a good shortcut to make that a little easier to learn. Well, perhaps I didn't find it, but I noticed it. So that key is, well, there's 3 parts to it. The first thing to remember is anything times 0, anything multiplied by 0, is 0. That's our first rule. Second rule is anything multiplied by 1 is whatever that number is. So I suppose I should put an example here. So for example, 0 times 5 is 0. Here I would have, say, 1 times 5 is 5. And the last thing to remember is, well, if I have one number which we'll write as A, and another number which we'll call B, and we multiply them, that will give me the same result as B times A. So using these 3 rules, we can chop down the number of products we have to memorize. You hear a sizzling in the background, that's me cooking my dinner. I like to multitask, kill 2 birds with 1 stone. In fact, I should probably turn that over. Who says you can't teach math and cook at the same time? Okay, so getting back to using our 3 rules, we can, like I said, chop down the number of products we have to memorize. So the first thing we can do is we say, since we know that 0 times anything is 0, we don't have to memorize any of the multiplication tables of 0 times a number or a number times 0. So all those are out. And since we also know that anything times 1 is whatever that number is, or one number times anything is, once again, whatever that number is, that throws out all of those. And finally, the real kicker is knowing that one number times another, so for example, what I said before, A times B is the same as B times A. That also saves us a lot of work. Some math educators watching this might be puzzled or object to me introducing the idea that letters can be used to represent numbers this early on. I disagree. I think it's good to, as soon as possible, introduce the idea that letters can stand for numbers, because that makes it a little easier when you get to algebra, and no one will flip out because they've seen letters used to represent numbers before. So anyway, so once we know this, I can summarize the multiplication tables you have to memorize. We don't need to memorize 1 times anything or 0 times anything, as I said, so you can skip straight to 2. So we need to know what 2 times 2 is. It's 4. 2 times 3 is 6. 2 times 4 is 8. 5 is 10. 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. Moving on to 3. Now since we already know what 2 times 3 is, we don't need to write 3 times 2. We can go straight to 3 times 3. So 2 times 3 is 6, and 3 times 2 is also 6. So that's why I'm skipping straight to 3 times 3, which is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. And I can't think of an easy way to do this on your fingers. I suppose if you were really curious to work it out, if you wanted to find out what, say, 2 times 3 is, that's 2 groups of 3, or rather 3 groups of 2. So you would just say 2 plus 2 plus 2 would be 2 and 2 is 4, and then 2 more would be 6. So that's what we mean by 2 times 3. It's a rapid way of adding. So 3 times 10, oops, we don't need to go that far. I'll go ahead and, when we finish up here, we should have about 36 products to memorize. So since we already know what 3 times 4 is, we can skip that. So 3 times 4, we said it was 12, and that's the same thing as 4 times 3 is also 12. So for the 4s, you can go straight to 4 times 4 is 16, times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32, and 4 times 9 is 36. You can, to learn these, you can either just look at the table or have someone read out to you 4 times 4 is what, and then supply the answer. You can make flashcards. Either way is fine. Moving on. Since we know what 4 times 5 is, we already know what 5 times 4 is. It's going to be the same thing, so we don't need to memorize what 5 times 4 is. We go straight to 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is 45. One moment, gotta turn my food over. Okay. Breezing right along through these. As I said, same pattern. Since we know what 5 times 6 is, we don't need to write down what 6 times 5 is. So we go straight to 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. 8 times 8 is 64. 8 times 9 is 72. And 9 times 9 is 81. So put it all together, we have 36 products to know. If you can memorize those 36 products, you should be good to go for multiplication. And the reason I'm not including any multiplication tables that have numbers greater than 9 is it's not really necessary, because if you know all the single digit products, you can figure out very easily what the larger products are. So once you've mastered the multiplication tables, you can start doing some more complicated multiplication problems. So suppose I had, say, 14 times 5. Well, we know that 5 times 4 is 20. Well, I suppose I'll show you the traditional way. So 5 times 4 is 20. You put the 0 down here, and you put the 2 up here. So the 2 from the 20 means 2 tens, so that goes up here. 5 times 1 is 5. 5 and 2 make 7, so the answer is 70. Another way to do this, and this is the way I think is a little easier to learn, is to break it down into parts. So first we have 5 times 4 is 20, and then we have 5 times 10 is 50. When we add the two together, we get 70. So breaking it down this way takes up a little more room, but I think it's a little simpler and you're less likely to make a mistake. And this is particularly true when we go up to, say, 2-digit multiplication. So if I had, say, 14 times, 18. So 8 times 4, we do that one first. 8 times 4 is 32. Then we have 8 times 10, which is 80. Then we have 10 times 4, which is 40. And then 10 times 10 would be 100. So adding those all together, I suppose, give myself enough room. 2 and 2 plus 0 plus 0 plus 0 is 2. Okay. 8 and 4 is 12. 12 and 3 is 15. Carry the 1. So our answer is going to be 252. So the easiest way to do these more elaborate multiplication problems is to break it down into single-digit products, or to products of single-digit numbers. I suppose the last thing I'll touch on, and we'll talk a little bit more about this later when I talk about shortcuts and mental math tricks, is when you're multiplying by 10, you can just count the zeros. So if I have, say, 10 times 3, okay, so 3 times 1 is 3, and then I just have 1 0 here, so I write 1 0 here. If I had, say, 100 times 3, I write 3 times 1 minus 1 is 3, then 2 zeros, and then however many zeros you want, it works out the same. 1 2 3 zeros, 1 2 3 zeros. And I suppose I'll end there. There are a couple more tricks involving multiplication, especially when we talk about fractions and decimals, but I'll leave it there for now. I hope you enjoyed this video, and thanks for watching.